All right. Activity 6-2, lemonade sales and height. So what we're going to look at here is a couple of different situations. And the purpose of this exercise is to help you see how you can write a mathematical expression to represent a situation, even if you don't know what one of the numbers in the situation specifically is. And this might seem strange to you, but we've already done this at the beginning of the year when we were looking at finding the area of rectangles and triangles and parallelograms. We discovered that we could write formulas to represent calculations for finding the area without actually knowing what the area was. So we knew the area for a rectangle was the length times the width, and the area of a triangle was 1/2 times the length times the width. So we could write expressions that represented the area without actually knowing the area. And then once we had a length and a width, we could substitute them into our expressions or equations and find those areas. So we've already done something like this, so don't let this intimidate you. All right. So A, Lynn set up a lemonade stand. She sells the lemonade for 50 cents per cup. Complete the table to show how much money she would collect if she sold each number of cups. So we're starting with 12 cups. We know each cup costs 50 cents. So we can just do 50 cents times 12 to find out how much money she'd make. Some of you, I know you can do this in your head, but I want to point out the calculation. So 0 times any of these is just going to be 0. So we kind of just end up with a placeholder. 5 times 2 is 10. Carry the 1. 5 times 1 is 5. Plus 1 is 6. And then in our multipliers, we've got 2 decimal places or spaces. So in my answer, I'm going to move my decimal over 2 places. So collect $6 for selling 12 cups of lemonade. 183 cups. Now, this isn't one I can do in my head as easily as this one. So this is the one I'm going to want to actually do a calculation for. So again, do that over on the right here. I need to do 50 cents per cup times 183 cups. 0 times all of these is just going to be 0. So I can just put my placeholder in. 5 times 3 is 15. 5, carry the 1. 5 times 8 is 40, plus 1 is 41. So I'm going to record the 1, carry the 4. 5 times 1 is 5, plus 4 is 9. So I get, oh, and then there's 2 places, 2 decimal spaces, so I move my decimal over 2 places in the product, and I get 91.50. Yeah, it's kind of lucrative if she can sell that many. I don't know how realistic it is to think someone's going to sell 183 cups of lemonade at a stand, but that's okay. Now, here we've got our unknown. This is saying I don't know how many cups of lemonade I'm going to sell. Let's just say it's any number C. What would the amount of money I'm going to collect be? Well, we saw for here, we could just multiply the number of cups by 50 cents. Here we just multiplied the number of cups by 50 cents. So here, if C is the number of cups, we can just say, well, I'm just going to multiply the number of cups by 50 cents. So I could say 0.50 times C. And that 0 here, when I'm talking about money, I want that 0 there. But if I'm talking about a formula, I could just write it as 0.5C. It's the same thing, right? So this is, we see we could write an expression for the amount of money Lynn is going to make without knowing exactly how many cups of lemonade she's going to sell. All right, let's move on to part B of this. It says, how many cups did she sell if she collected $127.50? Be prepared to explain your reasoning. Well, I know my expression for the amount of money she's going to make is going to be 0.5 times C. And I'm being told now the amount of money she made was $127.50. So that means 0.5 times C must be equal to $127.50. So I'm going to write that. 0.5 times the number of cups she sold is going to equal $127.50. Now I want to figure out what C is, and we've already had practice with this type of equation. I want to know what 1C equals, so I'm going to divide it by 0.5, because 0.5 divided by 0.5 will give me 1. So I'm going to divide that side by 0.5, but to keep my equation true, and I have to if I want to actually have a solution, I've got to divide the other side by 0.5 as well. So on my left side, 0.5 divided by 0.5 is just 1C. That's what I want. I'm just going to write C now. And then I've got to do this calculation. I'm going to come over here and just make a long division problem out of it. So I've got 127.5 divided by 0.5. I want to get rid of the decimal, and I can do that in a division problem by moving the decimal point the same number of spaces in both the divisor and the dividend. So I'm going to just move my decimal point there, and move that decimal point there. All right, 5 won't go into 1. It goes into 12 2 times. 2 times 5 is 10. Subtract. 12 minus 10 is 2. 5 won't go into 2, so I'm going to bring down that 7. 5 goes into 27 5 times. 5 times 5 is 25. Subtract that. That leaves 2. 5 won't go into 2. I'm going to bring down the last digit, 5. 5 goes into 25 exactly 5 times. So I'm left with no remainder. And that means that C is equal to 255. So she sold 255 cups. All right, moving on. So now we have our next scenario. And this one is height. Elena is 59 inches tall. Some other people are taller than Elena. Complete the table to show the height of each person. So we've got the first row is the name of the person. The second row is how much taller they are than Elena. And the third row is the person's height. So we know Elena's 59 inches. And this row tells us how much taller they are than Elena. So we should be able to add this number to 59 to get the person's height. So 4 plus 59 means that person's going to be 63. Lynn is 6.5 inches taller, so we're going to add 59 to 66.5, and we get 65 and 1/2. And then Noah, here's our tricky one. It's not telling us how much taller Noah is than Elena, but we know he's this much taller, and she's 59. So Noah is going to be B plus 59. Just like we did here, 4 plus 59, 6.5 plus 59, B plus 59. So there's our expression representing each person's height. Their height plus 59 inches. I mean their difference in their height plus 59 inches. All right, part B. If Noah is 64 3/4 inches tall, how much taller is he than Elena? So now they're actually telling us how tall he is. And we know that that number is equal to D plus 59. So I can say 64 3/4 inches has to be equal to the difference in their height plus 59 inches. And I just said this can be solved just as an equation. And we've solved these types of equations in previous lessons in this unit. So to solve this, I need to get D. I want to know how much 1D is, because that's the difference in their height. by itself. So I need to subtract 59 from the right side of the equation. But again, to keep my equation true and balanced, I need to subtract 59 from the left side as well. So on the right side, 59 minus 59 is 0, so that just leaves 1d. And on the left side, 3/4 minus nothing here. There's no fractional part on the 59. Leaves 3/4. I can't do 4 minus 9, so I'm going to borrow. 14 minus 9 is 5, and then 5 minus 5 is 0. So the difference in Noah and Elena's height is 5 3/4 inches. So Noah is 5 3/4 inches taller than Elena. Okay, and that's it.